Okay, so 33 does not factor by grouping, with the little box, or by grouping method. So we're going to have to do P's and Q's. So Q is plus or minus 1, and P is plus or minus 1, 3, 5, and 15. Okay, so we're going to set up with synthetic division, because before I do that, P over Q are these numbers over these numbers, but because this is just a plus or minus 1, we're going to end up with this list right here. So P over Q is this list right here. Okay, so now we're going to set up for synthetic division. Okay, so starting with 1, and you bring down the 1. 1 times 1 is 1, minus 9 is negative 8. Then negative 8 times 1 is negative 8, plus 23. That's going to give you 15. And then 15 times 1 is 15, minus 15, that's going to give you 0. Okay, so this one worked, so I didn't need all of this space. This here is a quadratic, x squared minus 8x plus 15. This one, factors of 15 that add up to 8, I've got negative 5 and negative 3. That adds up to negative 8 and multiplies to give you positive 15. So for 33, they want you to write each function in factored form. So they want you to make a list of all possible roots. So here's that part of the answer. And then to write g of x in factored form, remember 1 worked, right? So that's going to be x minus 1. And then for the quadratic, I've got x minus 5 times x minus 3. So here's the polynomial in factored form. Alright, so 34 does not factor by grouping either. So the p factors are plus or minus 1 and plus or minus 2. Those are the factors of the constant. And then for q, I've got plus or minus 1, 2, 3, and 6, because those are factors of the leading coefficient. So I need my p over q. Now this one I am going to have to, I can't just take the list of p numbers, because I've got q's are like all these other ones, so I've got to take those into account. So I'm going to take each of these and put it over that one, then over that one, then over that one, then over that one. So 1 over 1 is 1. 1 over 2 is 1/2. 1 over 3 is 1/3. And 1 over 6 is 1/6. Then I take the 2, this one right here, and I'm going to put it over this, 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 and this. So 2 over 1 is 2. 2 over 2 is 1, and it's already there. And then 2/3. And 2/6 is 1/3, right? When you reduce 2/6, it's 1/3, so it's already there, so I'm not going to write it again. So here's my list of possible rational zeros. Okay, so that's the first part of the question. And now we have to find the zeros. So let me set up synthetic division. Alright, so I set it up because I don't know how many tries I have to do before I get the 0. So bring down the 6, and then 6 times 1 is 6, minus 7 is negative 1. And then negative 1 times 1 is negative 1, minus 9 is going to give me negative 10. Negative 10 times 1 is negative 10, plus 2 is negative 8. So that one didn't work. I'm going to try the 2. I'll start with the whole number. Bring down the 6. 6 times 2 is 12. 12 minus 7 is 5. 5 times 2 is 10. 10 minus 9 is 1. 1 times 2 is 2. And 2 plus 2 is 4. So that one did not work, unless I made a mistake. Yes, I made a mistake. The coefficient for the constant is negative 2. Okay, so that threw off. Let's see. Maybe this the negative 8 is wrong. So negative 1 times negative 10 is negative 10, minus 2 is negative 12. So let me fix that to negative 12. And then right here, 2 times 1 in the second row, 2 times 1 is 2, 2 minus 2 is 0. So that's going to be 0 right here. So this one worked. So now I have this quadratic, 6x squared plus 5x plus 1, and then factors of 6x squared that add up to 5, that's 2x times 3x. So I'm going to factor with the box method, 6x squared, 2x, 3x, 1. Greatest common factor in the first row is 2x, and this would make that one 3x, and then 1 and 1. Okay, and it works. So in factored form, it would be h of x equals x minus 2, and then 2x plus 1, and 3x plus 1. Okay, and that's it. So 35, they want you to solve and find all the roots. That means imaginary, irrational, real, rational, irrational, all the roots. This one does not factor by grouping, so, or the box method, so I'm not gonna, do that. I'm gonna have to use P's and Q's. So for P's, it's plus or minus 1, 2, and 4. For Q, it's 1, plus or minus 1, and 3. So we need to make the list of P over Q, because these are the ones that are actual, the actual possible rational zeros or roots. So I'm going to take the P numbers over the Q numbers, so I get plus or minus 1, plus or minus 1/3. Then plus or minus 2, plus or minus 2/3. And then 4, and plus or minus 4/3. So this is the list of possible rational zeros for this polynomial. So now I'm going to set it up for synthetic division. Okay, so there it is. I'm going to start off with 1. So you bring down the 3. 3 times 1 is 3. 3 minus 10 is negative 7. 1 times negative 7 is negative 7. Plus 10 is 3. 3 times 1 is 3. 3 minus 4 is negative 1. So that one didn't work. I'm going to try 2. Bring down the 3. 3 times 2 is 6. 6 minus 10 is negative 4. 2 times negative 4 is negative 8. Negative 8 plus 10 is 2. 2 times 2 is 4. 4 minus 4 is 0. So that one works. So we don't need all this space. And so this here is 3x squared minus 4x plus 2. And so you check, is 6x squared, are there factors that give you negative 4? And they're not. So it's not going to factor, so that means you have to use quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's going to give you 4 plus or minus, this is 24, right? 12 times 2, 24. So negative 8 all over 6. So 8 is 4 times 2. So the 4 is going to come out, and the negative is going to come out. So you're left with 4 plus or minus 2i. This 2 right here stays inside. Doesn't have a partner. And then 6. I can factor the outside numbers by 2. Move it up a little bit. So this is going to be 2. Let me just show you that. Plus or minus I radical 2 over 2 times 3. So now I can cancel out the 2's. And so the roots are the 2 that I found through synthetic division, and then 2 plus or minus I radical 2. Now 36 does factor through the grouping method. So 2x cubed minus 3x squared, 8x minus 12. Factor out x squared from the first row, and then 2 times x squared is 2x cubed. Negative 3 right here, and then 2 goes into 8 4 times, so 4. And 4 times negative 3 is negative 12. So I get x squared plus 4 minus 3. Okay, so you set this equal to 0, and you get x squared plus 4 is 0, x squared equals negative 4. Take the square root, so x is plus or minus 2i. And then from this one, x is 3 over 2. So those are your 3 zeros right there. Alright, 37 also factors by grouping, so I set it up in a little box. You can do the grouping. Negative 3x squared, 4x minus 12. Greatest common factor is x squared. I get x here, negative 3, and 4 right there. So it's x squared plus 4, x minus 3. So coincidentally, that's the same factor we got right up on number 36. So x is plus or minus 2i, and then for this one, 3. So for 38, I can factor out an x. And notice how I forgot the parentheses. The only factors of 1 are plus or minus 1, so I'm going to start with 1. 1, negative 5, 3, and 1. Bring down the 1. Negative 4, negative 1, and it works. Okay? And so this one's a quadratic, x squared minus 4x minus 1, which does not factor, so I have to use quadratic formula. So x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c. C is negative 1, negative 1, all over 2a. So 16 plus 4 inside the radical, so that's 4 plus or minus radical 20 over 2. Now 20 is 4 times 5. So the 4 comes out, so you're left with 4 plus or minus 2 radical 5 all over 2. I'm going to factor out a 2 over 2. That cancels, right? So those are your 2 zeros right there. So the roots are zeros. Remember we factored out an x over here? So that's a 0. That's a factor, so that's going to be 0. Then through synthetic division we got 1. And through quadratic formula we got 2 plus or minus radical 5. So those are your 4 roots right there. So for 39, if you're going to divide by x minus 2, you have to have a positive 2 inside the little synthetic division. So student A is correct. And what student B did that's incorrect is that they put a minus 2. So that's their mistake. This is the correct setup.